I recognize Mr. Hultgren for 5 minutes.
Thanks, Madam Chair. Thank you all for being here. This is an important subject, and really appreciate the work that you're all doing. I think the NITRD program is important and gives federal agencies the ability to better work together in multidisciplinary fashion to tackle the big scientific and technological challenges we are beginning to face. Dr. Seidel, it's very good to see you again. It was so good to be at your amazing, literally amazing facility back in April. Still talk about that often, and I've visited quite a few different wonderful sites in Illinois. We do have a proud depth of scientific ecosystem in Illinois, but one of the most impressive was being there at Blue Waters. So just want to thank you for your work and encourage my colleagues, whenever you get the chance to come to Champaign, Urbana, to be able to see a phenomenal facility that is absolutely having a big impact. So thank you for your work. In your written testimony, Dr. Seidel, you mentioned that NCSA is deeply engaged in numerous big data projects. I also appreciate your discussing the LSST project. I think it's important for my colleagues to know that this was the #1 on-the-ground priority in the last Planetary Science Decadal Survey. So the work you are doing primarily with NSF funding really enables all of our other scientific fields. With our computational capabilities being what they are today, how does the government need to account for what many are calling more of a data management problem than a computing problem? And would you agree with that assessment?
Thank you very much for all those remarks. There are major challenges in data management. That's for sure. I would call it an expanding universe that is growing beyond the traditional HPC investments and so on. So it's a much bigger set of problems, and we're still grappling with them. There are many aspects of this, from what do you do with all the data? So whether it's data that are collected from telescopes or from accelerators or from light sources and so on, or the output from supercomputers, you have to figure out what to do with all of that. The data are scientifically valuable, and they also have economic value as well. And in fact, the entire Materials Genome Initiative that was announced 4 or 5 years ago, when I was at the NSF, I played a role in that, was a lot about making data, computing, theory, and experiment all integral to an approach to materials that was really an economic development initiative, because it was aimed at industrial competitiveness and making new materials at a much cheaper cost in half the time. And it was all largely seen as data being the integrator. And so creating services that make data that are collected from scientific activities, making them available to other researchers helps to ensure the reproducibility of the science. It helps others to take advantage of it more quickly, and it makes it directly available to industry so that they can take it up more quickly and then begin to make things. And that was what the materials genome was about. So there are many, many issues, and I'd say the data issues are growing rapidly, just as are the computing ones. We can't forget about them. They go together.
For years, industry and governments alike have used flops as the benchmark standard for our fastest computers. I think this is a certainly valuable measure which should not be abandoned, but what other ways do we need to be looking at our computational abilities to make sure that we have the most capable machines? Dr. Seidel.
We have a lot of work to do in every aspect, as we heard, on the technologies themselves, on the expertise of the scientific communities to take advantage of these machines. They're getting harder to process or to program. If you have 1 million processors, the Blue Waters computer has close to 1 million processors. Think about how you would program such a machine to do a problem in astrophysics or in biology. So we have to invest a lot in the training of the next generation of researchers. That's really, really critical. And in fact, I had the privilege to meet with about 60 students from the Exceed project who were at a conference in St. Louis this summer. And I queried them, and they all said that they were not learning what they needed in their university curriculum. They were learning it in these workshops that we were holding. So there's a lot that needs to be done in every aspect of this.
You also discussed the Strategic Computing Initiative, and I've been in touch with Dr. Blasey now at NIU, who was encouraging this kind of initiative when he was at OSTP. Earlier this year and in the previous Congress, the House passed my legislation, the American Supercomputing Leadership Act, which would create a dedicated exascale program and ensure a more open facility to the broader research community. I agree with the three leadership agencies in the initiative, and I think it's important to stress to my colleagues the national defense needs, mainly in workforce development, that are developed first outside of DoD with students and researchers at NSF and DOE. Quickly, and I'm just about out of time, but how should we improve our interagency working groups at NITRD to better serve our research capabilities and connect the core capabilities certain agencies have? Also, if you, maybe we can follow up in writing too, if you have further comment on PCAST review, that may be helpful as well.
I would just make a quick answer to that. Just, I think the recommendations actually were excellent. I think that they need to be acted on, and I'm very confident that they will be. I'd like to see a broader set of activities, though, that also really deeply engages the science communities. The NITRD program does focus naturally on the technologies, and so, but the science communities and the engineering communities are the ones driving this, so they need to be engaged.
Great. Thank you. Thank you, Madam Chair. I yield back.